Hello and welcome to another GCSE revision video, and in this video we're going to be looking at irrational numbers and surds. Okay, so what is an irrational number? Is it a number that's just having some kind of an emotional breakdown or something? An irrational number is a number that cannot be expressed in the form a over b, where a and b are both whole numbers. Which brings us to surds. A surd is simply an irrational number reduced to its simplest form, although these days we usually think of a surd if it's an irrational number that's in its simplest form involving a root. So when it comes to simplifying, we consider a number to be in its simplest form if there is no factor of the radicand that can be written as a power greater than or equal to the index, and there are no fractions under the radical sign, and there are no radicals in the denominator. This was taken from a Wikipedia article. Okay, so there was quite a lot of terminology there. Taking the technical terms one at a time, the square root sign or the cube root sign or whatever, that little tick-shaped sign, that is a radical. When we multiply two or more numbers together, the result is called a product, and the numbers that we multiplied together to make the product are called factors. The values that are to be square rooted or cube rooted or whatever, the values inside the radical, are called radicands. And the little number inside, just outside the tick, which will either be a 2, 3, 4 or 5, which tells us whether it's a square root or a cube root or a fourth root or a fifth root, that is called the index. Sometimes there will not be an index there. You'll just see the radical sign with no index, and if there is no index at all, we assume it's the square root, so we assume the index is going to be a 2. Okay, so suppose we're asked to simplify the square root of 24. Well, the first thing we need to consider is there a factor of the radicand that can be written as a power greater than or equal to the index? Note that because it's the square root, we can't have a factor of 24 that can be expressed as a number squared. Okay, so the first job is to break the number down into its prime factors. So 24 would be 3 times 2 cubed, and you'll note that 2 cubed is bigger than 2 squared. So we have an index here, because 3 is bigger than 2, that is bigger than the index of the square root. So the square root of 24 is not in its simplest form. So we can now look to see if any of those factors can be combined to make a square number. In this case, 24 can be written as 3 times 2 times 2 squared. We can then recombine the remaining factors, so 24 is equal to 6 times 2 squared. Now we can pull the squared number out of the square root. We just need to remember that the square root of a times b is the same as the square root of a multiplied by the square root of b. So the square root of 24 can be rewritten as the square root of 4 times 6, which can be written as the square root of 4 times the square root of 6, but we know the square root of 4 is just 2, so the square root of 24 is 2 times the square root of 6. Now this is a surd because it's an irrational number put in its simplest form. Okay, let's try a number like, say, the square root of 2/3. Can we simplify that? Which brings us to our second consideration for whether or not a irrational number is in its simplest form. There cannot be any fractions under the radical sign. Now, to get rid of the fraction under the radical sign, all we need to remember is that the square root of a over b is equal to the square root of a divided by the square root of b. So the square root of 2/3 is just the square root of 2 divided by the square root of 3. Now the question is, does that satisfy the conditions for being in its simplest form? Well, no, it doesn't, because a number to be in its simplest form cannot have any radicals in the denominator. Okay, so let's have a go at simplifying the square root of 2 divided by the square root of 3. Well, if the denominator is just a square root, we can get rid of the square root from the denominator by multiplying top and bottom by the denominator, because if you take a square root and multiply it by itself, then that gets rid of the square root. If it's more complicated than that, all we have to do is look for whatever number we can multiply the denominator by that will get rid of the square root. So for example, if we had something like root 2 over 2 plus root 3, we can take advantage of the difference of 2 squared, and if we multiply by 2 minus root 3 over 2 minus root 3, well, 2 plus root 3 multiplied by 2 minus root 3 is just going to be 2 squared minus root 3 squared, which is 4 minus 3, which is 1, and that actually eliminates the entire denominator. You don't have to eliminate the denominator altogether, you just have to make sure there are no radicals on the denominator. Okay, well, so much for the theory. Let's have a go at putting some of this into practice. Let's try simplifying something like the square root of 200. No, let's say 300. Okay, well, let's start by checking, does it meet the first criteria that it can't have any factors that can be raised to the power of a 2, because this is a square root, so we assume the index is a 2. Well, the square root of 300 is just the square root of 3 multiplied by the square root of 100. Now, 100 can be written as 10 squared. So if we take the 10 squared out of the square root, we've just got 10 times the square root of 3, which is now in its simplest form. So this is an irrational number in its simplest form, so this is now a surd. Okay, let's try something else, like say something like the square root of 75. Okay, well, let's break that down into its prime factors. Well, 75 is equal to, well, that's 3 times 25, which is equal to 3 times 5 squared. So we can pull the 5 squared out. So if the 5 squared comes out of the square root, then it just becomes 5, because the square root of 5 squared is 5. So this is equal to 5 root 3. Okay, let's try something slightly more tricky. Let's say we are asked to give the exact value of the square root of 300 plus the square root of 75. Now, if you come across something like that on an exam, there are two big mistakes that people make, and one is to simply combine them. The square root of 375. Easy, because 300 plus 75 is 375, so the square root of 300 plus the square root of 75 is equal to the square root of 375. This is wrong. This is a mistake. The square root of A times the square root of B is the square root of A times B, but the square root of A plus the square root of B is not the square root of A plus B. Let's try an example just to see. Let's say that the square root of 25 plus the square root of 9. We think that that should be equal to what? The square root of 25 plus 9. Well, 25 plus 9 is 34. Well, 34 doesn't have a whole number that's a square root, but the square root of 25 is 5, and the square root of 9 is 3. But 5 plus 3 is 8, and 8 squared is 64. So no, the square root of 25 plus the square root of 9 is not equal to, well, it is equal to the square root of 64, but that's not the same as the square root of 34. So that would be wrong. You cannot add the square root of 300 plus the square root of 75 and get the square root of 375. Another wrong approach would be to say, well, these are not like terms. We cannot combine unlike terms. So you just put can't be combined, or words to that effect. That would also be wrong on an exam. While it is true, you cannot say, I have 3 bananas and I add 4 apples, therefore how many oranges have I got? Yeah, okay, that doesn't make sense. And you cannot combine unlike terms, but are these terms really unlike terms? The only way we can find out whether or not they're unlike terms if we simplify them, and then we'll know whether they can be combined or not. Well, we've already looked at the square root of 300 is equal to 10 times the square root of 3. And we've already seen that the square root of 75 is actually 5 times the square root of 3. So actually these are like terms. I've got 10 root 3's and I've got 5 root 3's, and I want to add the 5 root 3's to the 10 root 3's. So how many root 3's have I got? Well, I've got 15 root 3's. So actually they can be combined, and the answer to that question would be 15 root 3. Okay, why don't you have a go at practicing some examples for yourself, and I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.